Hey YouTube, I'm Sergeant Indy, and welcome back to my turn-based strategy tutorial for GameMaker Studio. This video we're going to implement our turn order, and that's not particularly interesting with only 2 characters, so we're going to make 2 more for a typical D&D party standard size of 4. Before we move on to that, though, we do have a minor bug, and I'll run the game. You don't have to run it if you don't want to. I'm just demonstrating a minor bug. It's not a bug yet. It's because it's not really a problem yet, but it will be by the end of this video if we don't do something about it now. So I'm going to left-click on Sandy, and then I'm going to right-click right on Sandy, and she deselects. Well, you'd think, like, okay, well, of course she deselected. That's not a valid node to move in, except it is a valid node to move in. So what's trying to happen here is we're trying to make a path out of only one point. We're just here, because there's no parent to make a point to. We can't really have a path of one point. So because of that, going to our objects and our actor, our end of path action is never going to run. And by the end of this video, this end of path action is going to be how we tell the game controller to move on to the next turn. So 2 things happen when you right-click Sandy. Essentially, 1, you would forfeit her turn, and 2, when you forfeited her turn, you're not able to move on to the next turn. So we've got to fix that. That's, again, not a bug yet. It will be by the end of this video. So let's go into movement range, and all the way down at the bottom, right after we do the color move nodes, we're going to do start.move node equals false. And that'll make it so that's not a proper square to right click on, and it won't try to build a path out of nothing, and it solves our problem. If you wanted to make that node's color white, you could just do start.color equals C_white. But personally, I think it's a bit more uniform of a look if it's the same color as the rest of the grid moving out from it. So I'm going to leave it. But at any rate, we can't right click there and ruin everything anymore. So green check out of here. And now we're ready to make our 2 new characters. We're going to do that really simply. We're just going to right click Sandy, duplicate. First thing you should notice is it gives you a generic object name. We're going to get rid of that. I'm going to call this first character Rizzo. And it still has the actor parent, and it's our first duplicate. This is why I'm going over all of it. So it still has everything set up just like Sandy was set up, to include the create event, all of it. So we need to go in here, and we need to go Rizzo. There we go. Green check out of here. And here, and just duplicate any one of them again. I'm going to call this one Sunny, so Sunny. Head into there. Instead of Sandy, this is going to be Sunny. Great. Green checks. Green checks. Awesome. All done with that. Except not all done with that. We made 2 new characters. We need to add them to the room. I'm going to put Sunny over here by Danny. And I'm going to put Rizzo over here by Sandy. Little diamond formation, that's fine. Now green checks. Now we're done with adding our new characters. Done. Okay, so this part of the tutorial, this video, is really not that complicated, and we're ready to get on to the meat of the coding for this episode. So almost all of this code, this episode, is going to be handled into our game controller. But first we need to head into our cursor step event and do some chopping. Let's head in there. Step, boom. Okay. So the turn order I'm going to teach for this series is an initiative system just like Dungeons & Dragons. Each character will roll initiative, and then it will be stored in the turn order based on that value. So what's going to happen here is that our game controller will have a turn order. When an actor's turn comes up, it's going to give that actor its actions. Then it'll give control of that actor to the cursor. So a lot of this code in here has just become obsolete. So we can take this entire left-click statement and delete it. Gone. Obsolete. Doesn't matter anymore. We're only using it to select characters, and that's going to be handled by the game controller now. Just toss it out. It's not useful to us anymore. One more piece to delete in here. We have to go all the way down to the bottom. When you see this else, so we've got if move node, do stuff. Else, deselect the actor. This needs to go away. We don't want our player, or ourselves while we're testing it, to be able to deselect our actor with a misclick, because if you deselect him, you can't reselect him. The game controller does that now. So with that done, let's close out our cursor, and that'll work fine just how it is. Get on out of here. Let's get into our game controller, We need to get to work in here. We're going to open up the create event. And right up top with our array declaration, and again, I like to keep my state declaration all the way up top, so I don't know. Just something I do when I pop up in a create event and go, oh, okay, this one has a state machine, because that's a pretty important piece of logical structure to work with, and it's good to have that reminder as far as I'm concerned. The first thing we're going to do in here is randomize. Okay, so we're finally going to add a bit of random chance to our game. This randomize function is going to grab a fresh seed for our randomization. Random seeds are kind of complicated to talk about. Essentially, when a computer picks a random number, it's got this great big gigantic pile of numbers, and it uses a seed, which is generally a number, to just sort of randomly pick stuff out of that, but it picks it out of that in a set order. So if you gave this thing, like we did a random set seed 106542 or 3, it would pick those numbers in the same order every time. That's why, I'm sure a lot of people played Minecraft, right? Everybody loves Minecraft. Well, when you give their world generation a seed, it builds the same world. Like if we all put in apple, we'd all have the same world. And that's because of how random number grabbing works. It's not really random. It's sort of picking through this huge pile of numbers in a certain specific order. So that's also why both the recent XCOM games, you could save your game and then take a shot, and then, I missed, and then you load your save and you take a shot, I missed, and you load your save and take your shot, I missed, what's wrong with this stupid thing? Well, what's wrong with the stupid thing is it saves the seed when you save your game, so every time you load it, it's going to be the same exact statistic shot every single time. There's nothing you could do about it, so, I don't know. Anyway, randomize will be sure to grab a random seed. How programs normally do this is they essentially look at your system clock, which goes, like we see 1049 here. It goes much further down than that. It'll just grab a group of numbers from 1049, 23 seconds, 508 milliseconds, and that's our seed. Done. So that's what randomize does. I believe that's how most games handle their randomization. So when you fire it up, they go, give me your clock. Done. Okay. So now we need to add stuff to hold the turn order. And I'm just going to do the rest of that up here too. So let's do turn order equals ds list create. I've been having some fat finger problems all day. So this list is going to hold our turn order. It's going to store the IDs of all the actors from highest initiative to lowest. And then we'll be able to step through it with the help of another couple variables. So turn counter equals -1. Turn max equals 0. Current actor equals no one. Okay, so turn counter is going to keep track of the current turn. And turn max will let us know when to go back to 0, which when an entire round is done. And we could, why do you have turn max? Just use ds list size turn order. Well, turn max makes things a bit easier to read. That's why we have turn max. Current actor is going to hold on to the ID of whoever's turn it is, and then, of course, hand them off to the cursor. And it's not really going to do anything glamorous. It's just going to let us know when to increment our turn counter. See, well, we'll get there. If the current actor is no one, that's how it knows to go on to the next turn. That's why we're starting this at -1 and this at no one. Because when it hits the first patch of code and it's time to run the first round, it's going to go, well, my turn order is no one. Let's go on to the next turn. It'll move this to 0, which will grab the first one from our ds list create. Pretty simple. Okay. We're going to set up a round counter as well. So let's talk about turn and round. So if Sandy goes, that's her turn. And then Sandy, Sunny, Rizzo, and Danny, all 4 of them go, that's a round. So one person has a turn, everybody has a round. So round counter equals 0. Okay, and later on we'll use this to keep track of effects which expire after a bit, like a buff spell or maybe some acid damage kind of thing. Whatever. Point is, it's not going to be useful for a few videos, but we will use it. So, green check out of here. And let's go into the step event. And we got our state machine here, ready to go. We'll get our initializing. It's our state machine framework, and it doesn't really do anything. But down at the bottom here where it says ready, we're going to change this to roll init. And that's going to be our next state. And that's where the characters are going to roll initiative to determine who goes in what order. So let's do that state now, or case. Case, roll init, colon, break. Don't forget them colons. That's a really easy way to have an error in here. So, in this case, what we want to do is go through every single actor, and then we're going to simulate the roll of a 20-sided dice, and then put them into the turn order list that we made earlier in the correct order. So, we need a structure to make sure we've got them in the right order. That sounds like a priority queue to me. So, why didn't we set up our turn order as a priority queue in the first place, right? Well, we can go through a list top to bottom pretty easily. You can use DSList find value to just sort of step through it one by one, like we have been doing with the neighbors lists in our pathfinding stuff. Priority queues don't really have that functionality for some reason, and you can only really access their data by priority or by name. And neither of those really work for what we want, so it's just easier to work with a list. So we're going to make a priority queue to get all of our actors in the proper initiative order, and then we're going to use that queue to put them into a list, and then finally we'll destroy the queue. All right, let's do it. So first, we're going to declare our priority queue. So temp init equals ds priority create. And now we're going to call every actor, and we're going to have them roll their initiative and add it to that queue. So with oActor, init roll equals irandom range 120 plus initiative. Simple. Okay, so irandom range 120. That will return a number between 1 and 20. But since we only want whole numbers, that's what this I is for. So random range 120 will return a number between 1 and 20, but it could return 3.5872, whatever. We don't want decimals, so we're doing irandom range, which is only integers, so only whole numbers, no decimals. Get rid of the decimals. Done. So both random range and irandom range, they're both really useful in different cases. You just got to make sure you pick the right weapon for the job. Obviously, I'm also calling on an initiative statistic here. Just make a mental note that we need to add that to our actor object when we're done. And what that variable represents is that our actor's initiative modifier, so some characters can be naturally predisposed to be a bit quicker reacting than others. Okay, but now we're ready to ds priority add. Hey, I typed it right the first try. So other.tempInit, because we want to add it to that tempInit priority list, and then ID, our own ID, and then init roll is the priority we're giving ourselves. Let's talk about this real quick. Let's talk about this other we're using. This right here. Bloop. Other is an interesting command we've got in GameMaker Studio. You can use it in a lot of places. So in here, we're using with oActor. So the game controller is calling every actor in turn and doing this code. And then they're doing this code. In the actor's code, we're using other here. What other does is essentially hold on to the ID of the other object involved in any particular interaction. In this case, the object that called the actor to perform this code, which is the game controller, that's the other. In collision code, you can call other to reference whoever it is you're colliding with. And I think there's a couple of other places where other pops up too, but it's mostly prominent with statements in collision code. You could do the same thing with this, like with game. That would work fine too, but other is going to be cropping up a lot from here on out, so I figured it's a good time to introduce it as just a general keyword kind of thing. All right, so now that this is done, we filled up our priority queue like we want it, and every actor is going to be in there, and they're going to be in proper order. Their priority is going to be equal to their initiative roll value. Now we need to feed all of that in order into our DS list. So while ds, priority size, temp init is greater than 0. DS list add, turn order, DS priority, delete, max, temp init. Okay, so remember that DS priority, delete, max, or min, when they delete that number, they also return the value of whatever it's deleting, whatever we put in there. In this case, we've got an instance ID in there. So what we're adding here is just, we're deleting that ID from here, but we're returning that ID, so we're adding that ID to the turn order list. Wow, not very good explaining that right now. Hope everybody got that. Okay, at any rate, with this, everyone will be in our turn order list in exactly the same order we want. So, now we're going to do turn max. And again, this is mostly just to make code easier to read later on. DS list size, turn order, there we go. That'll keep track of how many actors are going in total. You could just do a DS list size every time. You can argue whether it's more efficient or whatever. It doesn't really matter, and I think turn max makes the code a lot easier to read than trying to have your brain mentally parse DS list size every time. So now we need to kill the queue and move on to the next state. So DS priority destroy, temp init, gone, and then what am I doing? After that, state equals ready. Okay. Now, ready. This state, let's go ahead and get started on that now. Case ready, colon, break. What this state is going to do is it's going to handle regular turn-to-turn operations. So we need to set it up to do a few things. First, whenever the currently selected actor is out of actions, we're going to have it switch the current actor variable in this game object to no one. And that'll be the controller's signal to go on to the next turn. So if the current actor is no one, we need to do some stuff. So if current actor equals no one, then turn counter plus equals 1. Great. So we've incremented the turn counter, pretty easy. Now, if that turn counter is above our maximum amount of turns, we need to roll it over back to 0 and also increment the round counter. So let's do that now. So if turn counter is greater than or equal to turn max, open squiggly, turn counter equals 0, and round counter plus equals 1. Great. So now with all that set up, we need to grab the next person in order. So after here, we're going to do current actor equals DS list find value. And I'm sorry, let's go ahead and pause if you're behind on rolling it. And if not, let's move up to get this up, easy to read up here, right? Turn order, turn counter. So that's pretty self-explanatory. We're setting the current actor equal to whoever's ID is in the appropriate space. And now we need to give them their action so they can have their turn. So current actor dot actions equals 2, and oCursor dot selected actor equals current actor. Great. So we've passed the cursor, the current actor. So the cursor's got control, the actor's got their actions, they're all completely ready to go. But not completely, because remember, we were calling movement range in that left to click event. That's gone now. We do this. So with that gone, movement range, and remember 3 arguments that go in here. First is the origin node, so that's map current actor dot grid x, current actor dot grid y. Then our current actor's move variable, so current actor dot move, and finally our current actor's action, so current actor dot actions. Great. Okay. All that's done. That's our turn order. Pretty easy. Now, one more thing to finish up. We need to go into our actor parent and add a couple more variables. Remember, we added an initiative and an init role to them. So green check out of here, green check out of here, actor, create, Now let's put it in these character statistics part. Let's do initiative equals 0, init roll equals 0, done. We're not done with our actor though. We're just done with our statistics. We do need to make another slight modification to our end of path event. So in here, if our action is a grid of 0, we just hand our ID back to the cursor so the cursor can control us, and we do movement range again. Great. But if our actions are 0, if we're out of actions, then ogame.currentActor equals no one. Okay, so there we go. The actor's out of actions. With this current actor equals no one, will signal the controller to move on to the next turn. Pretty simple. Green check out of here, all the way out. And let's run our game and see what we've got. Hopefully no typos. I probably made a typo. My fingers haven't been cooperating today. All right, so it's Danny's turn. Great. So let's make a mental list of whose turn it is. Let's move here. Now it's Rizzo. So Danny, Rizzo, Sandy. Danny, Rizzo, Sandy, Sunny. This will be back to Danny. Great. So Danny, Rizzo, Sandy, Sunny. So our turn order's looping, and it's going through properly over and over, and it should keep the same order all the way through over and over and over again. Now, let's close this out, and we're going to run it one more time. Why we're doing this is to see if we have ourselves a random turn order. Danny, Sunny, Sandy, Rizzo. Okay, so it looked a little suspicious at first, but this is a different turn order than we had last time. I'm going to kill it one more time just for thoroughness sake. Thoroughness? That doesn't sound right. Why is it always giving me Danny first? Danny, Rizzo, Sunny, Sandy. Danny, Rizzo, Sunny, Sandy. Danny, Rizzo, Sunny, Sandy. Danny, Rizzo, Sunny, Sandy. Okay. Sandy. There. Okay. So it's just statistically unlikely or whatever, but we happen to get some pretty similar turn orders a few times. The point is, it is random, and the turn order is working. So that's it. All right. That's our turn order. We've all wrapped up for today. Next video, we're going to give these guys, well, over the next few videos, we're going to give you guys something more interesting to do, but we're going to do basic player statistics next videos. Thanks for watching, everybody. If you're enjoying the tutorial so far, be sure to like, subscribe, or follow me on Twitter at Sergeant Indy, and try to ignore my poor squeaky chair. If you have anything to say, or need help, or just want to say hi, go ahead and leave a comment below.